Alright, this LeetCode question is called Trapping Rainwater. It says given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it is able to trap after raining. So this array down here is actually represented in this diagram. So as you can see, the total amount of water is 1, 2, 3, 4, 5, and 6, which is our result down here. I don't know if the amount of rain is measured by volume or height, so I apologize in advance if I go back and forth between those two terms.
Alright, so let's say we have two buildings. One building has a volume of 3 and the other one has a volume of 5. Now let's say it starts to rain. How much rain would be trapped between both buildings? The amount of rain trapped would be the same as the building on the left, which would be a volume of 3. But how did we figure this out? What we did was we started at the height of the building on the left, which was 3, and we went to the right until we hit another building. But what if this were the scenario instead? Alright, so now the building on the left is the taller one, and the building on the right is the shorter one. If we used the same methodology as before, so let's start at the building on the left and make that the water level, we'd get the wrong answer. The water would definitely not get up to the height of the building on the left. It would actually stop at the height of the building on the right. So now we have to update our thinking. How did we get the result this time? This time we got the right result by getting the height of the building on the right and going left. But we actually did this doing two different steps. First, we went from left to right. Then we went from right to left. And what we did in practice is that we took the value of both of those lines, one line being 5 and the other one being 3, and we kept the value of the minimum of those two. We need to do the same thing for our diagram on the left as well. We need to get the height of the building on the right and go left. So there we did this. We look at both lines, so one being 5 and one being 3, and we take the minimum of those two. Alright, so we're almost all the way through our explanation of how we got to our answers, but there's one piece we're missing. We've gotten the maximum height of the water level from looking at the height of the building on the left and the height of the building on the right, and taking the minimum of those two. But how is there water there at all? Obviously, because there's no building there. So when you think about it, what we're doing is finding the height of the water level and subtracting the height of the building. The height of the building here is obviously 0. Why is there no water here? Because the height of the building here is 3. And why is there no water here? Because there's a building there with a height of 5. So what we're doing, in reality, is we're taking the height of what the water level could be. So here would be 3, here would be 3, and here would be 5. And we're subtracting the height of the buildings. What's 3 minus 3? That's 0. What's 3 minus 0? That's 3. What's 5 minus 5? That's 0. So the total amount of water is 3. Let's do it one more time for the diagram on the right. Let's first determine the height of what the water could be. So it could be 5 here, it could be 3 here, and it could be 3 here. But now we have to subtract the height of the buildings because there can't be water where there are buildings. So we'd subtract the height of this building, that's 5, the height of this building, which is 0, because there's no building, and the height of this building, which is 3. So again, we have 0, 3, 0, add those up, and that would give you the total height of the water. Alright, so let's just do a much longer example just to solidify our understanding. First, we're going to get the theoretical water level by going left to right, and then we'll get it by going right to left. Then we'll take the minimum of both of those lines, and finally, we'll subtract the height of the buildings that are there to get the total height of the water. All right, let's begin. So going from left to right. All right, so let's start with our building with a height of 1. So the water level could be here, and it would stop here. Then we have a building with a height of 2. So the water level could be here, and it would stop here. Then we have our building with a height of 3. So it would go here, and it would stop here. All right, so that gets us a step closer in the right direction, but it's obviously not the answer yet. So now we have to go from right to left and do the same thing. All right, so we have a building with a height of 1, so the water level could be there. Next, we have a building with a height of 2, so the water level could go all the way across here. All right, then we have a building with a height of 3, so that could go all the way across. And now that I think about it, the water level going from left to right for the first building should have been this. Okay, so now we have our 2 lines. Remember, what we have to do now is we have to take the minimum value of both of those lines. All right, let me just label the x-axis to make it easier to read. Okay, remember now what we have to do is find the minimum of the green and the red line, because that would be the theoretical max height of the water. All right, so let's just label this max water level. All right, what would the max water level be here? We have the green line at 3 and the red line at 0. So we take the minimum of those two, so that's 0. Now we move to the building to the right of it. What's the minimum of 1 and 3? That's 1. Next, what's the minimum of 1, because the red line is at 1 again, and 3? That's 1. All right, so now we have the theoretical maximum levels of the water. And now what we have to do is we have to subtract the height of the buildings to get the actual water level. So we'll call this building height. All right, so now we have the theoretical height of the water and the buildings in that same space. So we just have to subtract those two numbers to get the actual height of the water. All right, so what's the actual height of the water level at the first one? That would be here. We have a max theoretical height of the water at 0 and a building height of 0. So 0 minus 0 is 0. How about here? We could have a water level height of 1, but we have a building there with the height of 1. So there can't be any water there. 1 minus 1 is 0. How about here? We have a theoretical water height of 1 and a building height of 0. So we actually do have water there. What's 1 minus 0? That'll give us a water level height of 1. Here, max potential water level height is 2, but the building has a height of 2. 2 minus 2 is 0. Here, we have a max potential water level height of 2 and a building height of 1. So the water level here is 2 minus 1, which is 1. Here, potential water level height of 2, building height of 0. 2 minus 0 is 2. Here, max potential height is 2, building height of 1. 2 minus 1 is 1. So when we add all those up, what's 1 plus 1 plus 2 plus 1 plus 1? That would give us a total water level height of 6. All right, let's get to the code. What LeetCode has given us is a function called trap, which accepts a parameter height. And what height is an array of values that represent the buildings or walls, or however you want to conceive of the things that trap the water in. All right, so the first thing we're going to do is we're going to check to make sure that the value passed in is not null. So we'll say if height equals null, we'll just return 0. And we need a value for the total amount of water. So let's say let total water equal 0, because that's where we are at first. And we'll actually save the length of the height array since we're going to be using it several times. So let length equals height dot length. And we're going to need two arrays. One is going to contain the values of the potential height of the water from left to right, and the other one is going to save the values of the potential height of the water from right to left. So that'll be let left max equal an empty array, and let right max equals an empty array. All right, and we'll go left to right first. So we need to set the first value in the left max array to the first value in the height array. So left max 0 equals height 0. Let's just move this up to give us more space. This will be the left max array, and this will be the right max array. Right now, the right max array is empty, and the left max array is equal to 1, because that's the height of this first building. This will be 1, 2, 1, 2. And of course, the empty space will be 0. Let's just put 0 there. All right, so now we're just going to go left to right, and we're going to save the values of the max height of the buildings up until that point. All right, that'll be for let I equal 1, and it's 1 because we've already saved the 0th index into our left max array. I is less than length, I plus plus, and we're going to make each index of the left max array equal the max of the same index of the height array and the previous index of the left max array. So what that's going to do is say which one's bigger, this or this. Well, 2 is bigger. Now what's bigger, 0 or 2? 2. Now what's bigger, 1 or 2? So 2. And finally, what's bigger, 2 or 2? They're the same. So the final left max array will look like this. And if you want to visualize the lines, that would look like this. In code, that's left max I equals the maximum of height I, which is the same index in the height array, and the max up to that point in the left array, which is left max I minus 1. All right, now we need to do the same thing, except going from right to left. So we'll set the value that's furthest to the right in the right max array equal to the furthest right value in the height array. So this will equal this. So in code, that's right max length minus 1 equals height length minus 1. All right, now we do the step where we fill in all the values in the right max array. And remember, these represent the theoretical max heights going from right to left. So that would be for let I equal length minus 2, go until I is less than 0, I minus minus. And inside that would be right max I equals the maximum of the same index of I and right max I plus 1. So the index to the right of us in the right max array. All right, so that would look like this, which is bigger, 2 or 1. So that'll be 2, which is bigger, 2 or 0. So that's 2 again. And we're going to go all the way across. To save time, I won't do every one, but at the end, it's going to be all 2s. And to visualize it, that would look like this. All right, so that gives us the maximum potential values going from left to right and right to left. So now all we have to do is find the minimum of those two values and subtract the height of the actual building there to get the actual height of the water. So that would be for let I equal 1. Why are we starting at index 1? Well, if you think about it, the value at index 0 can never be added to the total. Why is that? If rain fell on it, it would all drain to the left side. And even if there were no building there, the same thing would happen because there's nothing to the left of it trapping it in. Let's continue. I is less than length minus 1, and then I plus plus. So the total water equals the minimum value of these two lines at each index. So that'll be math.min of left max I and right max I. But that'll just give us the max potential height of the water. There might be a building there though, so we have to subtract the height of the building. So minus height of I. So what's the potential maximum here? It would be 1, but there's a building there, so we have to subtract 1 from that. Next one, what's the potential max? It's 2, but there's a building there, so we subtract 2 from that. Next one has a potential height of 2, and there's no building there, so we subtract 0. Next one, potential max of 2, but a building there with a height of 1, so we have to subtract that out. And finally, potential max of 2 there, but also a building with a height of 2 there, so we have to subtract that. And that would give us 0 here, 0, 2, 1, and 0. What's 2 plus 1? That would give us total water of 3. So if we go back to the code, we just have to return total water. All right, let's just run the code, see how we did. Oops, I forgot to add the plus sign here because we're not resetting the total every time. We're adding our results to it. So let's run it again. All right, looks good. Let's submit. All right, so our code worked. As usual, the code and written explanation are linked down below. If you liked the video, please give it a like and subscribe to the channel. It helps out a lot. See you next time.